Lesson 5 is still algebra, and we're talking about properties, okay? We want to predict two things we're going to learn about. So we're going to learn why the order of two numbers are added or multiplied does not change the answer. The order that they are added or multiplied does not change the answer, right? For example, 2 plus 3 is the same thing as 3 plus 2. 8 times 4 is the same thing as 4 times 8. Okay, that's what we're talking about. And we are also going to learn why the way in which numbers are grouped when added or multiplied also does not change the answer. Okay? All right, so in the real world link, Angelica and Nari are baking cookies for a bake sale, fundraiser. Angelica baked 6 cookie sheets with 10 cookies each on them. Okay? So how many total cookies did Angelica bake? So if she had 6 cookie sheets, right? 6 cookie sheets, and there were 10 cookies on each of those sheets, right? She had 6 of them. How am I going to figure out how many total cookies she made? Multiply. 6 times the number of cookies. 6 times 10, right? So 6 times 10 is 60. Now it says Nari baked 10 sheets with 6 cookies, right? So 10 little sheets with 6 cookies on it, right? So how are we going to figure out how many total cookies she made? 10 times 6. Very good. And here you can see 6 times 10, that gives me 60. And of course, if we flip it around, that's the answer. If we flip it around, 10 times 6 still is 60. So the answers are the same, right? So it does not matter if we multiply 10 times 6 or 6 times 10, we will get the same thing. Clear? So now we're going to use properties to compare expressions, okay? Now here, you need to know these definitions. So you need to put these definitions in your spiral, okay? So here we have the commutative properties. Now you guys, it says commutative, not communitive, okay? It says commutative. Now it says, the commutative property says the order in which two numbers are added or multiplied does not change their sum or product. Okay? The order in which two numbers are added or multiplied does not change their sum or product. So for example, here we have the 7 plus 9. 7 plus 9, same thing, 9 plus 7. 4 times 6, when you flip it around, still gives you 24. 6 times 4, same thing. That is the commutative property. Now, it is very important that you identify if you're talking about the commutative property of addition or the commutative property of multiplication. I would like for you to make sure that you write of addition or of multiplication when you are identifying. Now, the associative property says that the way in which 3 numbers are grouped when they are added or multiplied does not change their sum or product. So here we have 3 plus the quantity of 9 plus 4 is equal to the quantity of 3 plus 9 plus 4. Remember, when I say the quantity of, that means that it's in parentheses, right? So here, 9 plus 4 is what? Bless you. 9 plus 4 is 13. And then 13 plus 3. 13 plus 3 is?
13 plus 3 is 16.
16. Okay. So now here I have 9 plus 3 is?
12.
12. And then 12 plus 4 is? 16. So you can see the values are the same. All right, so same goes with multiplication. So here we have 8 times the quantity of 5 times 7, and we have the quantity of 8 times 5 times 7. So we have the 5 times 7, and then we're going to multiply the 8. that will give us the same thing if we multiply the 8 times 5 first and multiply times 7. It will give you the same product, okay? Now, the identity property. The identity property says that the sum of an addend and 0 is the addend. Does everybody know what an addend is?
No.
The addend is the number that's getting added. So those, 13 and 0, those are the addends. Is everybody clear? Okay, those are the addends. So for the identity property of addition, you see how I said of addition, right? The identity property of addition says that if I add an addend, any addend, to 0, what am I going to get? That same addend, right? So you're going to get the identical number as you started with, right? See, identical, identity. Does everybody see the correlation there? Now here, it also says that the product of a factor and 1, the product of a factor and 1 is that factor. So for the identity property of multiplication, the number that you're going to multiply to get the same number, not 0, is 1. So the identity property of multiplication says if you multiply any factor times 1, you'll get that same factor. All right, so properties, okay? You need to have this definition in your notes also. Properties are statements that are true for any number. Properties are statements that are true for any number. If the numbers that you put into the properties don't work, then the property does not hold for that operation, okay? So, properties are statements that are true for any number. All right, so the expressions, like we talked about in the intro, 6 times 10 and 10 times 6, those were both equal to 60, right? So those are called equivalent expressions. And the reason they're called equivalent expressions, of course, is because they have the same value. Is everybody clear?
Yes.
So equivalent expressions have the same value. Okay, they have the same value. All right. Also, that 6 times 10 and 10 times 6, that illustrates the commutative property because we're just flipping them around, right? So here we want to determine the two expressions that are equivalent. Okay, we want to determine whether the two expressions are equivalent. If so, we want to tell what property is applied. And if not, we want to explain why. So here we have 15 plus the quantity of 5 plus 8. And we have the quantity of 15 plus 5 plus 8. Okay? So here, this is which property? When I'm moving the parentheses, it is the associative, right? So this is the associative property. Now we want to see if they are equivalent. So now we just simplify. So 5 plus 8 is 13, and 13 plus 15 is 28. On the other side, we have 15 plus 5 is 20, plus 8 is 28. So they are equivalent, and this is how we write it. We use the symbol with the equal sign. Here we have the quantity of 20 minus 12 minus 3, and we have 20 minus the quantity of 12 minus 3. Again, moving the parentheses, what property do we think this is going to be? Associative. Now, if we end up with not an equivalent expression, that means that for this operation, the associative property does not hold. Is everybody clear? All right, so now we simplify. So 20 minus 12 is equal to 8 minus 3 is equal to 5. And then 20 minus the quantity of 12 minus 3. 12 minus 3 is equal to 9. And then 20 minus 9 is 29 minus 9 is 11. So are these equivalent expressions? No, they are not equivalent expressions. And this is the symbol that we use to show that. We write those are not equivalent expressions. The next example, we want to determine whether the two expressions are equivalent. And if so, we want to tell what property is applied. So here we have 34 plus 0, and we have 34. So 34 plus 0 is equal to 34, and 34 is just 34. So are they equivalent? Yes, they are. Now let me ask you this. How does it stay equivalent? What did I add here? I added 0, okay? So because I'm adding 0,
It's identity.
that is the identity property of addition. Very good. So they are equivalent, and here by the identity property of addition. I want you to make sure you write of addition. Yes. Whoops. The next one, we have 20 divided by 5, right? And we have 5 divided by 20. So here, 20 divided by 5 is
4.
equal to
4.
4. Very good. Now, I got to show you this here. 20 divided by 5 is 4. Now we have 5 divided by 20. Is that equal to 4?
No.
No. If we had, if we write this as a fraction, it would be 5 divided by 20, right? That says 5 divided by 20, right? Then we can simplify by dividing by 5. And then we end up with 1/4. So, because we have 4 here and 1/4 there, they are not equivalent. Is everybody clear?
Yeah.
All right. So, the expressions are not equivalent because the commutative property does not hold for division. Does everybody see that explanation? That is what you're going to need to do when it says to explain. For the next example, it says determine whether the two expressions are equivalent. If so, tell what property is applied. So here, we have 5 times the quantity 6 times 3. And we have the quantity of 5 times 6 times 3. So, now we simplify using our order of operations. So, because we're moving the parentheses from the second group to the first group, that is the associative property of multiplication. Very good. So let's see if we have we have to see if they're equivalent, right? So we have 6 times 3 is 18. And then we have times 5 over here. So 5 times 18 is 90, right?
It is?
Yeah. And then on the other side, we have 5 times 6 is 30, right? So that's 30 over here, times 3, which is 90. Are they equivalent?
Yes.
Yes, they are. And we wanted to identify the property, and we said it was the associative property of multiplication. So ASSOC, property of multiplication. I am okay if you abbreviate that.
Can
like
we just
that.
put associate?
All right, the next one, we have 27 divided by 3, and we have 3 divided by 27. So 27 divided by 3 is
79.
9. And 3 divided by 27. 3 divided by 27 is equal to?
It's 1/9.
Right. 1/9. So 9 and 1/9, are they equivalent?
Nope.
No, they are not. So that means, and when we flip them around, what property are we trying to illustrate? Commutative. Very good. So we say here that the commutative property does not hold for division. All right, so now we're going to use properties to solve problems. Let's look at these examples here. It says, in a recent season, Kansas Jayhawks had 15 guards, 4 forwards, and 3 centers on their roster. Write 2 equivalent expressions using the associative property that can be used to find the total number of players for their roster. So the operation we're going to do is we are adding. Very good. So this is going to be the associative property of addition, right? And what are we adding? We're adding 15 and 4 and 3. So the 2 expressions that we will write are 15 times the quantity of 4 plus 3. That's one of them. And then we can move the parentheses to the first 2. So then we'll have the quantity of 15 plus 4 plus 3. Sorry, I meant plus. Okay? So this is 15 plus the quantity of 4 plus 3. Okay, and then the other expression is the quantity of 15 plus 4 plus 3. And then you can check to see if they are equivalent. Okay? So 4 plus 3 is 7. Plus 15 is 22. Over here we have 15 plus 4 is 19. Plus 3 is 22. So they had 22 players on their roster. So Brandy earned $7 babysitting and $12 cleaning out the garage. Write 2 equivalent expressions using the commutative property that can be used to find the total amount she earned. Okay? So since we're looking for the total, right? What operation is it?
Plus.
Addition, right? So this is the commutative property of addition. So what are we adding? For babysitting and for cleaning the garage. Very good. So the 2 expressions are 7 plus 12 and 12 plus 7. Is everybody clear? And of course, we can check to see their equivalency, of course. This is going to be 19 is equal to 19. Got it?
Yeah.
All right. All right. The area of a triangle can be found using the expression 1/2 b times h. 1/2 times b times h, where b is equal to the base and h is equal to the height. We want to find the area of the triangle shown. So here, what am I going to put in for the base? 15. Very good. And what am I going to put in for the height? 12. So we have 1/2 times 15 times 12. Now, with the associative property of multiplication, that tells us we can multiply in any order we want to, right?
Mm-hmm.
So, if I wanted to, you guys know multiplying times 1/2 is the same thing as doing what? Dividing by 2, right? So, which one would be easier for me to divide by 2, 15 or 12? 12, right? Because it's even. So, I'm going to multiply 1/2 times 12, which gives me 6, and then 6 times 15, which is equal to 90. So, the area underneath this slide is 90 square feet. Is everybody clear? All right, so example D. It says Vicki earns $6 an hour while working 11 hours over the weekend. She put 1/3 of what she earned in a savings account. How much, find how much she put into the account, okay? Now, if you look at this, this tells me how much she put in her account, right? 1/3 of what she earned. That's how much she put in her account, correct?
11 hours.
So here, that's 1/3 of what she earned. Okay? Now, in that expression, in this phrase, what does that of mean? Of in math means multiplication, right? So this means multiply. Okay? So 1/3 times what she earned, right? So what am I going to do to find out how much she earned? If she earned $6 an hour and she worked 11 hours. 6 times 11, right? So this is going to be 6 times 11, okay? This is how much she earned, right? So it's 1/3 times how much she earned. All right, so now, rather than having my parentheses, my grouping symbols around the 6 and the 11, I can move it to the first two, multiplying 1/3 times 6. So now, I'm going to move the parentheses from the from the second two to the first two factors, right? So this is going to be equal to 1/3 times 6, 1/3 times 6 times 11. So now, 1/3 times 6 is equal to 1/3 times 6. And remember, it's the same, multiplying times 1/3 is the same thing as dividing by 3, right? So this is going to be equal to 2 times 11, which is equal to 22. 22 what? Dollars. $22.